Hi everyone. So in this video, what we are going to do is to tackle our order storage test. But in order to do that, I would like to spend a little bit more time on one prerequisite for that, which is actually the refactoring of the test data creation. So the reason for that, and this is actually what we'll cover in this small video, the reason for that is let's look at actually our test case or like at our various test cases that we have and see how we actually deal with test data. So let's take, for example, this product storage test here. And if you take a look at the at the test data that is generated or is created here, we have a lot of those kind of things. We create objects and then we set some random names or some whatever attributes, and then we sometimes we do it here in this test case directly. Sometimes we create us like a little bit of a helper method here in order to make it a little bit more concise. But just imagine the next test, then you would have to do something like this again. And all of this seems to be a little bit more ad hoc. So we can also see it like here. And so then, there is a lot of stuff that is actually perhaps even needed in this test case. So I'm not really sure, like if I now look at this particular test case, I'm not really sure if it's really needed that actually this is written here, or if it's only needed because otherwise there would be a side effect created, like because, I don't know, there's a violation of any kind of not null constraint or something like this. But actually it doesn't really belong to the test, and actually it doesn't bring any value to read it here, and it just creates noise when we actually read through it. So I was just thinking on how to make that a little bit better, and perhaps I will just now go ahead and create you or like show you a tryout that I have done and what benefits it actually brings. So my idea here is that I will go ahead and create test data in a more structured manner, and that for all the tests that they can basically rely on this layer of test data generation. And so that you don't have to do it like in one method here and then some other unrelated stuff here and all this stuff that is not so nice to read then afterwards. So let me just do a git stash pop. So I have right now in my git stash like 5 classes or something, and if I put them back here, then what you will see here now that we have like a couple of changes in the build Gradle, in the entity, and then a couple of classes. And perhaps let's go through them one by one in order to understand what is actually going on. So first of all, in this build Gradle, so you can see here, by the way, on the IntelliJ, this green bar here indicates that this is something that has happened or that is new in the Git status. So these lines I actually added. And what I did here is I created, basically, I added 2 dependencies. So the first one is Lombok, and this is also Lombok here, but just for the test code. And then we have another library which is called MapStruct. And those 2 libraries, I will use them throughout this improvement here in order to come up with a better approach for creating test data. And I will probably go through that when this makes sense to explain it to you. So let me just create a proper build, and then then everything should be compiled and so on. So while this is doing that, so perhaps let's go at the first point here. So at the end, perhaps we can actually take a look at the storage test on how it afterwards looks like, so that you get a better feeling on how it actually improves the situation. So here now you can see how I changed the creation of the product data, or the product in this case. So if we go here, we could also, there's an IntelliJ feature which is called local history for selection, and probably we can already leverage that. So, and here you can see the diff on how it has been before. So like before, what we had is, the interaction with the data manager, and then we set create, and then set name, set description, and then we saved the product through the data manager. And now we have a bean which is called products, and this has a save method. And what we have to pass in here is some kind of data, and there's another method on products which is called default data, and then we can set these values in. And then at the end we can say build, and then it will return actually an object that is then being able to be saved. And this right now it doesn't look like a very much improvement. In fact, actually it's a little bit longer, but we will see that next where this really shines, or how this improves the situation. So yeah, so the reason, or let's I think the next thing that we can go through is actually taking a look into this beans here. So I created an API, let's say, in the test directory, which I, under this directory test data here, which I called products. And this products basically has three methods. So first of all, it has a method called default data. And this default data will give you back an object of type product data, or actually a builder of type product data. So, and the interesting part here is that I define all the attributes of the product with already some default value. In this case, category is not set, but at least like the name is set here. And with that, when we now use that in a particular test, we don't care about the name, then we basically have this default name in here, and we do not really have to write in our so for example, here we just care about the category, right? So we just say products.default data, and then we just pass in the category, and this is about it. So this basically means we have a valid object that comes back here, and then we can only override the stuff that we really care about in this test, in this particular test case. And if you look closely into this method, then you will see that this is not actually of type product, so not our JPA entity, but actually of type product data. So let's look into this one here. This is a second class, and this is a little bit interesting. So right now we have or previously we just had our product object, and this is just a JPA entity. And now what I have created is I created like a super small class which just contains those business attributes like name, description, category. And I used the builder annotation. And this actually, if we look here, this comes from this Lombok library, and also this value annotation here, which basically makes that an immutable value object. And so what these annotations now do is that they actually will generate source code when we compile to this particular class, so that, like if we look here in this product data builder, so first of all, there's now a method called builder, just because I used this this annotation, and then there are methods for all the attributes like name, description, category, and so on. And this has then as well been generated by this, or by the builder that has been generated. And with that, we basically create an abstraction on top of the product. It's actually, you can think of it like a data transfer object or something like this. And so yeah, so perhaps I mean this explains already this default data thing. But now if we call build on this operation here, then as you can see by IntelliJ, it will actually return object of type product data. And if we now go back to our test case, then this means that this object is actually of type product data. So now comes the second part into play, which we will use. And here, this is the save method, and the save method, expects a product data like this DTO object, and not already the product object. So let's see how this is going. So this is in the test source code. This is mainly for really interacting with the test data, but this product data actually lives in the production source code, and so does this other bean here, which is called product repository. So let's actually, this one we can actually get rid of, and this one as well, because it's not needed in this class. It basically delegates the save operation to this product repository. So let's look into this one. This is another class that I created, and basically what this does is it takes a product data like the DTO object and saves. It basically converts it into a product object, like in this JPA entity, and then it saves this product in the database, and then returns actually the data, the database JPA entity. So so this is already familiar to you, probably, like the data manager that we just use in order to save the object. But here is the last part, which might be of interest for you, which is this product mapper class. And there we have the responsibility to convert a product data object to a product object. And this is where the second library, MapStruct, comes into play that we have seen here in the build Gradle. So writing this mapper, copying all the values from all attributes is normally not really something that is worthwhile to do. And luckily, there is a library which actually does that on our behalf. Which is called MapStruct here. And what we have to do is we have to create an interface called product mapper, or just an interface, however we want to call that. And then we actually annotate that with this mapper annotation. And then we just have to declare a method, which is called, we can call it whatever we want. And based on the input parameters that go in here and the result parameter, it will actually generate a corresponding implementation of that interface. So this is basically what this library does. And so this means that we don't have to, do all this mapping on our own. So if we want to look into the implementation that actually got generated, we can go here and click this button. And then if we go in the project tree here, we can actually see that this sits under build, generated, and then this implementation. And this is actually not very it's actually just regular Java code. And here you see this mapping logic. So there's project, and then it says set category, and then takes the category from the product data and so on. So this is just the mapping that goes on here. And there's one particular aspect in the usage of MapStruct when we use it together with Jmix, which is that, as you might remember in our test previously, or I think we have another test where this is actually still used, we in Jmix normally don't create objects by just using a new product or whatever, right? So this and the reason why we not do that is because for example, if we would have some lifecycle callbacks, so for example, we could say post construct or something, then these methods would not be called, and therefore it's normally advised to just do that as part of this data manager, and even like IntelliJ or the Studio plugin actually, says to us entity is created by calling constructor. It is recommended to use data manager create. So this is actually what we do. Now, if we just use the coming back to the MapStruct here once again. So if we just leave it up to the library to create a product object, then it by default would actually use the constructor. And this is what we have to prevent. So there's a particular parameter to the annotation which is called users, and then you can define some bean or some class that actually should be used by this particular implementation. And if we go here, so this is just a regular component, and the interesting part comes here. So there is a method which is I called it create entity, but it doesn't really matter. And the important aspect is that there needs to be a target type annotation on the class that gets in. And then, we do our logic in order to create that. And basically, by this annotation and the return type, once again, MapStruct will identify that this is actually something that should be used for the construction of the object. And if we look here into this product mapper impl once again, then we can actually see that it has auto-wired this Jmix entity factory, and this is because I said please use this one here. And then it basically understood that this is for the object creation, and then it says it calls this method create entity and passes in this product class here. So with that, we actually have now achieved that we will basically the actual object creation will go through this Jmix entity factory here that I also created. And I think with that we have now covered all the aspects. So besides that, there's just nothing really special. I was just thinking, so there's this entity repository. I have not implemented this interface here. So this would be product of type product data and product. And the reason why I just created this interface is, if we want to do this or basically mirror this whole approach for all the entities, and this is actually what I have to do, and I will do it in after the video, then this is actually a little bit nicer to have a common interface that all those repositories share. Okay, and with that, we now basically have our test data setup a little bit more improved. Right now it's only for those two tests, but this beans this bean for products here could be used on all the tests. And with this test data here, for example, it's now a little bit more concise. Even in particular, we see it here because we don't need to really care about the name and so on and so forth. So with that in place, I think we have now achieved a little bit better test data generation, and also this showed you a little bit on how to interact with just standard Java libraries in order to interact or use them in a regular Jmix application. Okay, so with that, I would actually close this video for now. And what I will do then after the video is basically copy this approach for all the entities. And then we can take a look at the result in the next video. And then we can actually use it for our actual test case, which is this create order storage test. All right, thanks for watching, and then see you next time.